we are trying to solve a problem in errors and approximation. The problem is like this. In an experiment, 4 quantities are having errors 1, 2, 3, and 4 respectively. That experiment physical quantity P is given using a formula. What's the error in P? Though here it is not mentioned, we shall understand that what he want to calculate is what is the maximum error. Even if somebody has not asked what is the maximum error, if somebody asks an error, we have to assume that he is asking for a maximum error, or otherwise he will be asking you what is an absolute error is in a given problem. Until he asks it, we shall always measure maximum error, because we shall count the error in a maximum possible way and make our preparations in accordance to that. It is given that the given relation is like this: P equal to a cube b square by cd. Then what is the error that is going to happen in the thing is something like delta p by p. That's what we are supposed to calculate now. There are powers to each of these physical quantities like 3, 2, 1 and 1, right? So when you are making an approximation delta p by p, you shall multiply with the power 3 delta a by a. 3 is a power, I have multiplied that as a factor. Plus, because we have to add errors in each of that. In B, there is a power 2, b square. So, 2 delta b by b. C. C power 1 is there. Therefore, 1 delta c by c. Here, I want you to give a word of caution and tell you that if you are looking for an absolute error, whoever is there in a numerator, we have to add a plus. Whoever is there in denominator, we have to add a minus. But if we are looking for a maximum error, whether it is a numerator or denominator, we shall always add the percentage of errors. So, and similarly for the d also, there is a power 1. So, 1 into delta d by d. And it is given further in the problem that error in A is 1%. So, 3 delta a by a is 1%. 2, error in B is 2%, delta B by B is 2%. 1, error in C is 3%, respectively, he said. Similarly, 1, error in D is given as 4%. So, when you add all of them, 3% plus 2 and 2, 4%, 1 and 3, 3%, 1 and 4, 4%. So, that is 3 and 4, 7, 7 and 3, 10, 10 and 4, 14%, right? So the error, the maximum error that what we get delta p by p error percentage of delta p by b is 14%. I just want you to give a word of caution that if you want to find out absolute error, what do is, being c and d in denominator, here you will put a minus for both c and d. Here you will get a minus, here you will get a minus. Then what happens? 3% plus 4% is 7%. This will become minus 3% and this becomes minus 4%. So altogether that becomes 7% minus 7%, that becomes a 0%. Fortunately, that answer is not there. Though even he has not asked for an absolute error, if you calculate an absolute error, you will get 0. So he is definitely not talking about absolute error, and he is surely talking about a maximum possible error. So the maximum possible error answer is a 14%. So even if 0% is there, see, when you are measuring a physical quantity, you will never get a 0 error, because there something will go wrong for many reasons. That's what errors and approximation chapter is. So it's like unlikely to say that I got a 0 error, right? That's how we have to go, because while you are doing experimental, for example, least count, there will be some least count for the device. So that's an error that comes with that device. So we have to live with that error, and we have to measure errors using this kind of a formulas, right? That's it. Thank you for watching.